So the second video of three, I think I'll make one more, and I'm just trying to look through these problems and anticipate any questions that you guys might have. So I circled the couple problems that I'll be doing in this particular video, and just going to go ahead and get started. For number 13, h prime of z, let me use this space up here. I can use all this space. So get set up here. H prime of z is equal to, we can see that we have the sine of something. So the outside function is the sine, so the inside function is the z to the sixth. So the derivative of the outside, the derivative of the sine is cosine of z to the sixth. And then we're going to multiply that by the derivative of z to the sixth, which is 6z to the fifth. Remember, we're taking the derivative of this function with respect to z. Okay, so then the next part is I'm going to take the derivative of the sine of z to the sixth power. Okay, so I'm actually going to write it like this. I'm going to do this in two steps. The derivative of, instead of it being sine to the sixth of z, I'm going to rewrite it like this. So this way, sine of z to the sixth power. To me, that is much easier to see how to work with it versus the way it was written before. So I can go ahead and just rewrite this first part, 6z to the fifth multiplied by the cosine of z to the sixth. And then we have the derivative of something to the sixth power. So now it's clear what the outside function is. The outside function is the sixth degree, or the sixth power. And so we take that power, we bring it out front, and then we multiply it by what's inside to the 6 minus 1, or 5. And then the derivative of the sine of z is the cosine of z. And that's it. That's it. Let me put a nice box around that. Okay. And then what else did we say? Number 16, got some ln, got an ln, a sign in there. F prime of x. Let me get the right color here. So for number 16, I'll write that up here. We've got f prime is equal to, you notice I dropped the x, it's consistent among throughout the problem, so we're okay there. Alright, so then the first function is the ln of something, and we know that the derivative of the ln of something is 1 over that something, and that something is the sine of x, so we have 1 over the sine of x multiplied by the derivative of the sine of x, and so that's going to be cosine of x. Alright, and then minus, that takes care of that one, that's it. Yeah, there's not anything else you can do with that. I'm just double checking as I'm talking to you, so yep, that's it for that. And then minus, we have something to the 10th power, and so we have the 10th power, bring that out front, so minus 10 times what's inside, x to the fourth, minus 3x to the 10 minus 1, or 9, and then multiply that by the derivative of the inside, and the derivative of the inside is 4x cubed, derivative of x to the fourth, minus the derivative of 3x, which is 3. And that's it. Okay, so they look kind of nasty. They look like they're going to give you a lot of problems here, but not so much there on that one. Debating whether to do any more here. I think I'll leave it at that, and then I'll look at the other problems, 18 through 28. So I will do here number 21. That looks pretty intimidating, and so I'm going to just go ahead and start this. K prime. So we have a quotient, and if I look at the denominator, I want low d high, right? Low d high. So the denominator would be x plus the tangent of 12x. So there's our low, and let me put brackets around that. And then multiplied by the d high. So the derivative of the numerator would be the derivative of 1, which is 0. The derivative of e to the negative 2x is e to the negative 2x multiplied by the derivative of negative 2x, which is negative 2. Okay, so that takes care of that part. That's the low d high. Okay, now I need minus the high d low. Okay, so always double checking what I'm doing. Minus the high. So let's do that. Let's write down the high, or the numerator, 1 plus e to the negative 2x hopefully I'm not going to run out of room. And then multiplied by the denominator, the derivative of the denominator, which would be the derivative of x is 1, plus the derivative of tangent of 12x. Well, the derivative of tangent is secant squared. Okay, so we have secant squared of 12x. And then multiplied by the derivative of 12x, which is 12. And I need a set of parentheses around that. Now, all of that would be over. I'm going to review this problem here just to make sure we're on the same page. So this is all over low squared. Well, the low is easy. We just rewrite it. X plus the tangent of 12x. And again, guys, I don't need you to simplify anything. Just get that and we're fine. So just to review what we did, we have the k prime is equal to the denominator, which is right here, low. And then, so that's the denominator. That's our low. Okay. And then this is our derivative of our numerator, d high. I'm just going to say d high. Low d high, that's the derivative of the numerator, minus, and then we have the high, okay, high, and then right here is our d low. Alright, the derivative of our denominator. And then over here we have our low squared. Low squared. Well, just in case you're wondering, well, why am I not doing all of these problems? Well, you have access to all of the solutions to each of these problems here. So I didn't think I needed to do them all, but I would be happy to help you. I'd be happy to post another video. Just let me know. It might not happen before Monday, but nevertheless, do as best you can. And this is kind of like a crash session in derivatives. Since you already have had this section, you've already gone through chapter 3, you've already done derivatives. I'm really just trying to give you as much practice as I can so we can get to future concepts that you guys haven't seen yet, so we can spend more time on the things you haven't seen. And I know there's a lot we're doing here today, but it'll pay off because we'll have time to settle in and spend more time. This isn't how the whole year goes. Just this is how it goes here in the first part of the year when you've already seen this material before. So be patient. We will slow down a little bit, but if you are a little rusty on your derivatives, hopefully after doing this assignment you're feeling a lot more comfortable and confident with your ability to answer any of these derivative questions. Alright, so the only real application problem from any of these problems that we've done so far today is this number 28. So I'm going to do that one, finding the equation of the tangent line, and that's what that means when it says find the tangent line. It just means to find the equation of the tangent line to this curve at that x value. Okay, so what do we need? Let's think about that first. What we need when we're finding the equation of a line is the slope, okay, and then we need a point, and we'll just call it xy. Okay, well, right now all we have is the x value. So if we think about this, we could find the y value right away, and why don't we go ahead and do that? Let's what is the function? Okay, it is an f. So f of 2 is equal to, so just so we can find the y coordinate, and then we can easily plug in that once we find our slope. But anyway, we have f of 2 would be 4 times the square root of 2 times x, 2 for x, so 2 times 2 here under the radical, and then minus 6, and it says multiply that by e to the 2 minus, in the function it says 2 minus x though, so we're going to replace x with 2 because we're finding f of 2. Okay, so probably a lot of words that you didn't need there, but anyway, 4 times radical 4, so 4 times 2 is 8, and then not equals but minus 6 times e to the 0 power, so e to the 0 power we know that to be 1, and 8 minus 6 is 2, so we have our y coordinate. Okay, so we have the point xy. Now we know what it is, so we can write that in. So the point xy is the point 2, 2. So we have that. Now all we need now is the derivative. We need the slope, which is the derivative when x is 2. So the slope when x is 2 is the slope that we need. Okay? And how do we find the slope? Well, we have to find the derivative of f of x. And so the derivative of f of x, let me do this in blue. Actually, let me choose a different color, green. So f prime is equal to the derivative of the first function. Yeah, here's the deal. I don't like, as I keep saying, I don't like to have, I don't like to take the derivatives of radicals, so I'm going to rewrite that as to the 1/2 minus 6 times e to the 2 minus x. Okay, now I can focus on the derivative and not have to try to do too much in my head. So we have 4 times the derivative of 2x to the 1/2, which is 1/2 times 2x to the negative 1/2. Okay, and then don't forget, this is the one thing that students always forget, and that's to take the derivative of the inside, and that derivative of the inside is 2. Okay, and so we've got, again, 4 times, that's that 4 right there, times the derivative of this guy. Okay, so just to review what we just did, the derivative of this guy is 1/2, bring the power out front, that's that, multiplied by the inside to the 1/2 minus 1, okay, which is the negative 1/2, but then multiply that by the derivative of 2x. Okay, so that gets overlooked all the time, and guarantee if it's a multiple choice test, if you put the 2 in there and get the right answer, great, but if you leave the 2 out, that answer will also be there because they know that's what happens, okay, when you're not paying attention. Anyway, we also then need to make sure we take the derivative of the next term, which is minus 6. Again, derivative of e to anything is e to the anything, multiplied by the derivative of the anything. Okay, the derivative of 2 minus x is equal to negative 1. So that's why we're going to put a negative 1 right there. Okay, and I guess we could simplify this a little bit before we put x equals 2, or 2 in for x. This 2 right here is going to cancel with that 2 in the denominator, and then we're going to get 4 times 1 over, now I can put the radical back in, so 2x to the 1/2 down here would be radical 2x, like that. Okay, and then minus, actually we have a minus times a minus, so that's going to be a plus there, 6e to the 2 minus x. Okay, so we have a pretty simple version of f prime of x, and so if f prime of x is equal to this whole expression, then that means that f prime at 2, which is exactly what we want, that's the slope when x is equal to 2, okay, and so f prime of 2 is equal to 4 times, it's just as simple then as replacing x with 2. Okay, so 4 times 1 over radical 2 times 2 plus 6e to the 2 minus, probably be nicer for you guys if I just replaced the, let me do this, let me replace this here with a red 2, so you know where I replaced, you know where I put that 2 in. Okay, and then what do we have here? We've got 4, so this guy right here, radical 4 is 2, that's a 2, and so 4 divided by 2 is 2. Alright, so we have 2 plus, and then this guy right here, e to the 2 minus 2, that's e to the 0, and e to the 0 is 1. So we have 2 plus 6, and that's 8. So there's our slope. Now that we have our slope, okay, if we go all the way back here, we know that our slope is 8. I'm going to put it right there. Slope is 8 right up here, and the point is 2, 2. So all we have to do now is use the formula, or use the equation, point-slope form of a linear equation, which is this guy. Okay, and we're going to replace y1 with our 2, our y-coordinate. We're going to replace m with 8, and then we're going to replace our x1 with 2. And that right there is the equation of the tangent line to the curve y equals f of x at the point 2, 2, or when x is equal to 2.